Hi, this is a video key for Do Now 14.3. So here we go. I'll be D-block today. And considering these 2 points, what is the vertical change from the first point to the second point? If we're going from the first point to the second point, what you want to do is subtract the y value of the second point, so the first point, from the second point. So we need to do 0 minus 22, which is simply negative 22. So the vertical change, okay, equals negative 22. Okay, and there we have it. So it's just the y value of the second point minus the y value of the first point. As we're going from 22 to 0, you're going down 22, and it should make sense that that is negative 22. Now, for the horizontal change, we're going from 0 to 25 because that's the x component. So horizontal change, or change in input in a function, because vertical change is change in output, horizontal change is going to be 25 for the x value from the second point minus the x value from the first point, which is 0, which is simply 25. And that's the horizontal change. Okay, I'm going to rearrange this just a little bit here. Okay, now we want to make a fraction of the vertical change over the horizontal change. So that's going to be vertical change of negative 22 over 25. And you have probably guessed it. This is, in fact, the slope. M being the letter we use for slope, for montan or mountain, because mountains have slopes. M is negative 22 over 25. Okay, so there's your equation, a reminder. And now Jimbo is at it again. He's done 3 efforts here. So first of all, he's trying to find the slope, and he got 25 over 22 instead of negative 22 over 25. So here's what I'm going to tell you he did. He took those 2 points. Okay, no, that's not what I needed to copy. He took these 2 points. Here they are, 0, 22, and 25, 0. And what he did, first of all, he's got a reciprocal and he's got an opposite. So first of all, he tried to get change of x over change of y. Okay, and so when he set this up, he put the x change over the y change. So he did run over rise. But the other thing he did was he did his subtraction back in 2 different directions. So I'm going to use this to illustrate this. So he switched this around. So he either did y1 minus y2 while doing x2 minus x1, or he did y2 minus 1 over x1 minus x2. So he did it the other way around. He flipped it. So he did change of x, but he went in 2 different directions with the subtraction. So when he found, let's say we're finding his change in y, he may have done 22 minus 0, and then 25 minus 0. And both of those are going to be positive. Or he might have done this. He might have instead done, for change of x, he may have done 0 minus 25, which is negative 25. Okay, he may have done that. And then he may have done 0 minus 22. So he would have gone in the opposite direction. So that would end up being negative 22. So he either did positive 25, he either went this way and then that way, or he went this way and then that way. And then he, of course, did change of x over change of y. And, okay, I'll just say, and he did his subtraction in opposite directions. That changes the sign of the slope. Okay, so he would have done, if he had done negative 25 and negative 22, he would have ended up with negative 25 over negative, let me do this here, see if I can get this to work, negative 22 which equals 25. Let me move things around here. I think I need to erase some stuff. Okay. There we go. Okay. Which equals 25 over 22. Or he could have just done 25 over 22 and been done with it. Depends on which way he went with the subtraction. But either way, he went in opposite directions with the subtraction, and he did the x change over the y change. And one of those is in the opposite direction from the other. So you need to keep the subtraction flowing in the same direction. And we're really considering output change over input change, because that's what we're often really concerned with in functions. When we start modeling things in the real world, like miles per hour, miles is going to be an output and hours is going to be an input because it's time. And miles per hour is a slope. It's a rate that you would use a function to work out. I hope that has, there was actually one more question to deal with, so I apologize. I was about to, actually 2 questions to deal with. So for B, so he's trying to identify the x and y intercepts of a line going through 0, 22, and 25, 0. He argues that the x-intercept is 22 and the y-intercept is 25. Well, you possibly remember that the y-axis is defined as places where x is 0. So 22 is actually the y-intercept, and 25 is the x-intercept, because the x-intercept is on the x-axis, and the x-axis is defined where y is 0. So his big mistake is he switched the axes. Okay, he forgot that x equals 0 on the y-axis and y equals 0 on the x-axis. And that's your big clue when you're looking at a couple of points. Where would you plot them? Well, this one would get plotted on the y-axis, so it's the y-intercept, and this one would get plotted on the x-axis. So it is the x-intercept. Okay, let's get rid of all of that. And last one, but not least, Jimbo corrected his work and declared that x and y-intercepts were 25, 22. This is a mistake I see happen a fair amount. 25, 22 is not on any axis. You need one of the variables, one of the values to be 0. This is not on an axis. 25 is certainly the x-intercept, and 22 is the y-intercept. But when you graph it, if I graphed it like this, 20, it's like here's 25, that's the 25, 0 point, and up here is 22. But if you graph 25, 22, that's out here. That is a legitimate point, but it's actually not going to be on a line that goes through these 2 points. It's just going to be out there. Okay, so nope. 25, 22 is not either an x or y intercept. So I hope that has helped, and I'll go ahead.